What if life did not start on Earth at all, but in a universe that was still cooling from the Big Bang? That idea sounds impossible at first, until you look at how quickly life appeared here, and how much the cosmos may have offered before Earth even existed. Earth formed about 4.5 billion years ago, and the earliest signs of life show up surprisingly early. That is a huge clue, because even the smallest cell needs a way to store instructions, build proteins, and copy itself without falling apart. That creates a classic origin puzzle. Proteins help run life, but a genetic system is needed to make proteins in the first place. Scientists have spent decades trying to explain how chemistry crossed that gap, yet the exact sequence is still unresolved. One reason this debate got new energy is genome growth. If you look across deep time, many lineages seem to have gained larger and more complex genetic toolkits. Some researchers argue that functional genome size increased at a rough average pace, like a long trend line running through evolution. Then comes the strange part. If you trace that trend backward, the math can point to an ancestor so simple that it seems to predate Earth itself. That does not prove life began elsewhere, but it does raise a hard question. Why does the timeline seem too long for our planet alone? The second idea is even wilder. In the earliest universe, everything was far too hot for liquid water. But as space expanded, it cooled. For a brief window, maybe tens of millions of years after the Big Bang, large regions could have reached temperatures where liquid water might exist. That matters because water is only part of the story. Life also needs the right elements, and many of those, like carbon and oxygen, are made inside stars. So the early universe had to wait for stars to form, live fast, and explode before chemistry could really get interesting. Some scientists think that happened quickly, in dense young regions. Massive stars may have formed early, then died as supernova, and spread heavier elements nearby. If the timing worked, some pockets of the cosmos could have had both usable temperatures and the building blocks for life-friendly chemistry. And water may not have been the only option. Other liquids, including ammonia or ethane, can remain usable at much lower temperatures. That opens the door to habitats that do not look like Earth at all, especially in a universe that was still young and uneven. If life began in those conditions, it may not have needed a perfect planet to survive. It could have sheltered inside warm planetary interiors, icy rocks, asteroid interiors, or even dust grains, waiting for better conditions before becoming active again. That is where the idea gets personal for our own solar system. Mars is one obvious place to look, because it once had flowing water and may still preserve ancient traces in buried rock or dry riverbeds. If life ever existed there, the evidence could be hiding in plain sight. Researchers care about Mars because old water leaves patterns in stone. Buried layers, cracked minerals, and ancient channels can preserve a quiet record of a wetter world, even after the surface has turned cold and dry for billions of years. Then there are Europa and Enceladus, two icy moons thought to hide liquid oceans beneath frozen shells. They are not Earth-like on the surface, but they may have the kind of protected water worlds where chemistry can keep going long after the surface looks dead. Enceladus is especially intriguing because its hidden ocean may leak material through the ice. That gives scientists a rare chance to sample a buried ocean without drilling through miles of frozen crust, which makes the moon a powerful test case for habitability. Titan takes the idea even further. It has lakes, rivers, and seas, but they are made mostly of methane and ethane. If scientists ever found life there, it would not prove a Big Bang origin, but it would prove biology can adapt to far stranger settings than most people imagine. That is why this question matters so much. It is not just about aliens. It is about how life begins, how it survives, and whether the universe itself may have been biologically active far earlier than Earth's own story suggests. Still, both parts of the argument remain speculative. The genome growth idea depends on assumptions about how complexity changes over time. The early habitable universe idea depends on assumptions about temperature, chemistry, and how fast stars appeared in the young cosmos. Those are serious scientific questions, not settled facts. But that is also what makes the hypothesis so powerful. It pushes astrobiology beyond the search for Earth-like planets and asks whether life may be woven into cosmic history itself. If future missions find biology on Mars, inside an icy moon ocean, or on a world as unusual as Titan, this debate will get much louder. For now, the most honest answer is also the most exciting one. We do not know whether life is a local accident or a cosmic habit. And if the universe really gave life a head start, then Earth may not be the beginning of the story at all. It may just be one of the first places where the story became impossible to ignore. So what do you think? Did life begin here, or somewhere much older?